In this lesson about the chemical parameters of soil, we will talk about two basic components of chemistry. First, we cannot discuss any kind of chemistry without acknowledging the master variable pH. pH stands for the power of hydrogen, and it tracks the acidity or alkalinity of a soil. The next step is also something abbreviated as CEC, or cation exchange capacity. So just going through this definition, cations are positively charged ions. Exchange capacity is just the ability of a surface to hold and release these cations. So first up, the pH of soil. Here's a table showing the common nutrients when we're concerned about agricultural products. So we've got nitrogen, phosphorus, potassium, sulfur, calcium, magnesium, iron, manganese, boron, copper, and zinc, molybdenum. As we can see, these bars kind of represent their availability, and so red and smaller means less available, green and thick means more available. And what you might notice here is that they're not all equally available at the same rate, at the same pH. Instead, there's kind of this narrow band between about 6 and 7 pH where most of these nutrients are most available for crops. That's why whenever you're looking into soil, even the most basic advice always tells you to get your soil to a pH of between 6 and 7. Except in rare cases, this is where you want to be, particularly for vegetable crops. Changing your soil pH is a relatively involved affair. You've either got to spread something like powdered limestone across your entire field to raise your pH, or spread powdered sulfur across your entire field to lower your pH. Both of these involve a decent amount of money, time, equipment, and just general headache to do, but you can't skip it because, again, pH, the master variable of chemistry, as we saw in that first diagram, you're never going to be able to access the fertility in your soil, the cations that you want to exchange from the soil surface, unless your pH is in the right range. Now that we've given the respect due to pH, the master variable, we can begin to look at CEC, cation exchange capacity, to investigate the fertility within our soil. So first, since CEC, cations, they are positively charged ions, you can infer that most soil particles hold a negative charge. So this clay particle, which has been vastly magnified, of course, has the capacity to hold 5 cations. It's got 5 sites of negative charge, so it can hold 5 cations in an exchange capacity. So if plant nutrients are typically positively charged, or cations, and soils are typically negatively charged, the next point is the exchange. And for something to be exchanged, it typically has to be suspended in water. So we would have some positively charged, some cations, floating around in the water around this clay particle. Now, of course, with basic chemistry, ions want to balance their charge, and so these free-floating cations will be drawn towards these bonding sites. Unfortunately, soil fertility management is not as simple as ensuring you have a high CEC. Even though you do need sites on your soil particles for fertilizing nutrients to bond to, it's not as simple as have fertilizer and it bonds to soil. The strength of the ionic charges of these soil nutrients are not created equal. There's something called a lycotropic series, which ranks ions in rough proportion to their size and charge in which one gets preferential bonding and which one can kick another one out. This is an abbreviated lycotropic series, which focuses on elements pertinent to crop production. When we talk about crop production, we're typically first focused on nitrogen. But if you look here, nitrogen's kind of ranked it only shows up once and it's kind of ranked low. So even if you add ammonium to your soil, there's no guarantee it's going to actually bond to the CEC. If there's a heavy presence of these cations here, they're going to be outcompeting the ammonium for bonding sites to the soil particles. So here's another complication. If these nutrients aren't bonding, then what that means is they're remaining in water suspension, so they're water soluble. On one hand, that's good because plants can typically only take up nutrients from the water of the soil. So they need to take up water-soluble nutrients. They need, the plants themselves actually need the nutrients which are not bonded to soil. So it sounds kind of contradictory, right? If you want a high CEC to maintain high fertility in your soil, but plants can only access what's not in the soil, what's not bonded to the soil, then what's the focus on CEC? Leaching, this is the problem. For a nutrient to be plant available, it basically needs to be water soluble, it needs to be dissolved in the water, but soil water does not stay in place. If it's not taken up by soil roots, it could be lost to evaporation, which would leave the salt behind. But leaching is concerned with water moving out of the system. There were nutrients in water within suspension between soil particles, and over time, gravity has drawn the water and these nutrients that we tried to add down and out of the soil, called leaching. All right, last thing. We're bringing this all back around. So you see this cation here, positive hydrogen cation. This is right back to the power of hydrogen, right? The power of hydrogen, the logged power of how many hydrogen ions there are in a system. And so pH is measuring how many hydrogen ions are there. CEC tells you how much fertility your soil can hold. But then that pH, remember that image from before, that pH is affecting the availability of all these nutrients because it's outcompeting everyone for a site on the soil CEC. So an incredibly acid soil is more or less filled with hydrogen ions, and that means they're all over all the soil particles, and all of this stuff is leaching because it's water soluble, or it's just been kicked off and it just leaches because it erodes out of the system. The important takeaway here is that soil chemical parameters are bound on soil particles. And so again, that brings up this topic of leaching. If they are not bound to soil particles, they will leach out with the water. If they are bound to soil particles and those particles erode from the system, again, it may not be technically leaching, but it's still a loss. And so maintaining your soil chemistry means paying attention to your soil physical parameters.